Hey there. So today we're going to build a simple tool use AI agent using pretty much pure Python against the OpenRouter API. And I'm going to walk you through kind of the whole process. I'm going to show you what it looks like when it's done, and then I'm going to walk through step by step how to build up that code so that you can build a simple tool use agent. So I want to walk through, these are the kind of points I want to hit. So first I want to hit the motivation for doing this in the first place. So really the motivation is that I think a lot of things in the world are or seem really complicated or are talked about like they're really complicated because they can be when you really get into the weeds and you're really at the fringe edge of a lot of these things, including AI agents. There's a lot going on, and there's a lot to keep track of. But I also think that in that you kind of lose the core understanding of what this is, and it's really easy for a lot of people, particularly non-technical people, but even technical people, to miss the forest for the trees. So I wanted to do this, to walk through explaining how to build this up from scratch, because I found that doing so myself really helped me understand what an agent is, how it works at a pretty core level. And then I think that's really useful for moving forward, working with AI in general. So I really just want to show you how simple it can be. That's really the point. So I have all of this code up on my GitHub as a gist already, so you can see this. If you're seeing this API key, don't worry about it. This is only going to be used for this video. You can feel free to try to steal it, but it will be deactivated, and it's credit limited anyway. So even if I forget, it's not gonna matter. But what I want to show you is what this looks like currently when it's working. So this is about 195 lines of code, all said and done with the tool definitions. There's only two tools defined here. They're very simple. But in less than 200 lines of code, you can see that we can create an agent here that can answer questions based on tools that you give it access to. So here I'm asking it to use its sum tool. It's going to use its sum tool and give me an answer to a super simple math problem. And then here I can ask it for book recommendations. So what are some good adventure books? And one of the tools that we gave it is this Search Gutenberg's book tool, which is a tool that I stole from the OpenRouter documentation for the most part. But it essentially just queries an open repository of books based on keywords. So we can see, if we run that, you can see that after a minute, it took a second to hit the API, but after it comes back, we get this nice description, obviously not very well formatted in just a terminal prompt. All the new lines and stuff aren't being, shown properly, but we get this response of, here's a bunch of good books based on your question using the tool call. And actually, I just noticed that this response didn't use a tool call because the model didn't, probably because we're using GPT-5 Nano for this demo. Okay, so I was actually having a little trouble getting GPT-5 Nano to properly use the book search tool. So I just switched the model over to Claude 4.5 Sonnet, and we should see it use it successfully now. And this is actually a great example of, you can't just put any model in any agent. You can't just put the cheapest model you want as the backbone of your agent. The model matters a lot. So it's important to pick a good one, and this is why you see and hear a lot about people using Claude and Anthropic models in particular for agent building, because they're actually just really good at calling tools and using tools. So, here's the response that we get. We can see it called a tool, it got its response, and then it gave us, an answer of some good books that we can read in the adventure genre. Okay, so that's a good example of sort of how this works. So now we're going to jump into a new directory and build it. Okay, I really like UV. Feel free to use pip or whatever you'd like. UV just makes things really easy and really nice. No affiliation, but I highly recommend it. Makes things really fast, and it manages virtual environments really nicely for you, which is one of the biggest pros. Okay, so this is what UV is going to give us when we set up that project. It's just an empty README, a main.py that runs nothing, and a basic py_project.toml. So let's go ahead and do the first thing, which is build the agent. So the agent itself doesn't actually contain the information about tool use, and it knows how to call tools, but it doesn't define the tools, and it doesn't know how to read the tools out of your code. But that we're going to start with the agent. So I'm just going to build a really simple agent class, and we're going to give that class an LLM client, which is going to be this OpenAI LLM client. So what am I doing? Why am I writing code in the PyProject.toml? Okay, let's jump back over here. So we're going to create an agent class. That agent class is going to need to have an LLM client and a max iterations for how many times it can call tools in its loop. One core thing to understand is that an agent using tools is essentially just an AI LLM running in a loop where it has the ability to say special things that tell you to call a function instead of return it output to the user. What I'm saying here is the agent is allowed to do that a maximum of 10 times before giving the user an answer. Okay, so this LLM client, we're going to get from the OpenAI SDK. So we're going to import OpenAI, from OpenAI. And yes, I am referencing the complete code over on my second screen, if you're wondering what I'm looking over at, just because I already have this, just completed. But I want to go through the whole process to show building it up. So we're going to import that OpenAI agent, and then we're going to set up that agent, the client URL and an API key. So that API key, I'm going to use the same API key I used over here. Because this is just for demo. Okay, maybe I should have picked better names for my teamwork sessions. All right, so there's the API key. The base URL can be any OpenAPI compatible URL. I'm going to use OpenRouter because I really like it and I find it really easy. It's a really good way to be able to call all different kinds of models. So I highly recommend it. And a lot of this code is based on OpenRouter's documentation. I just found that hobbling it together into an agent loop like this kind of really helped me understand things. So this is the setup for our LLM client and our max iterations. Now we need to create the agent, and it's going to take a whole bunch of stuff. So it's going to take a model. It's going to take a tool mapping, which we will get to the tool mapping later. It's going to take tool schemas. Messages, this allows you to pre-populate it with messages if you'd like. We're not going to do that here. And we're going to give it a prompt and a system prompt. Okay. So we're going to initialize these things. So what these are is this is going to be, the schemas are going to be the LLM appropriate description of how to use these tools. So it's going to be strings that explain to the LLM what tools it has access to, what inputs they expect, and how it can call them and what output it's going to get back from them, right? The tool mapping is the other side of that. It's the thing that allows us to take that output when the LLM decides to call a tool. We can take that output from the LLM and map it over to a particular function that we're going to call in order to give that agent the response. So we'll get to building that up, but I wanted to explain that here and not just totally blow past it. So just a couple of like safety things for initialization. Like you need to give it, you need to give it something. So if you don't give it a prompt or any messages, we're going to raise an error. Messages or prompt required for agent initialization. Okay. And then likewise, if we have both, we can only accept one, right? Because the messages essentially contain your prompt. Only messages or prompt allowed for agent initialization, not both. Okay. Now we are going to set messages to messages, which if it's not passed, we'll just set it to an empty list. And then, oh, okay, yeah. So if prompt dot messages, how do we format? Okay, yeah, so this is a dict with role. So this is where you can see how, you're either going to pass in a messages array that already exists, or you're going to pass in a new prompt to start it from scratch. Generally, we're going to be passing in a new prompt, but this lets you use your agent. You can pre-populate it with context if you would like to. We're going to let it gather all its own context from tool calls, though. And then likewise, if system prompt, we do self.messages.insert 0, and then we just insert that system prompt into our messages array. So it's at the very beginning. Okay. So now we have the initialization of the agent good to go. So we can come down here into our main function and we can initialize the agent. So we can say agent, and we're going to give it all those things we said before. So we're going to actually move the API key up here. Okay, ignore my atrocious Vimfu. And then we're going to add the model ID up here as well. And that's just going to be Anthropic. What is it? Claude Sonnet 4.5. Is that how they format the... Yes, it is. So that's going to be our model string. And we can go ahead and replace this with this. Okay, so now we're calling that from that constant, and then we're going to initialize this with the model ID, as well as our prompt, which we're just going to grab very simply from the command line prompt. sys.argv0 is the name of the file we're running. sys.argv1 is the first argument. So we're just going to pass a string as the first argument. Super simple. Okay. One thing I'm going to do real quick is just back out of Vim and actually not yet. So we're going to jump over here and we're going to add OpenAI to the dependency array. We're also going to need a couple other dependencies. So we're going to go ahead and add requests, and I believe we also need docstring parser. Let me double check that here. Requests, docstring parser, and OpenAI, yes. Okay, so those are the three libraries that we're going to need. And so what I'm going to go ahead and do is save this and make sure everything is saved. And then I'm going to back out and I'm going to run our main file. I did forget to import sys, but that's fine. This will let me activate the virtual environment, which is just going to give... Oh, no, it won't until I fix that. That's fine. WQA. Has that created? Okay, so that is going to create the virtual environment for me. And so now we can go ahead and activate that. And that's just going to help NeoVim and my LSP understand all the things I have installed a little bit better than it would by default. It's complaining because we're not passing in tool mapping and tool schemas, but we're going to get to that later. So don't worry about that yet. Okay, the next thing that we need is a basic way for the agent to call the LLM. So let's build that. So, and all we're doing here is it's just a simple function that uses this LLM client, which is just an OpenAI instance from the OpenAI SDK, and it's going to call chat completions on that. We're going to give it the model, because we're making an API request, so we just need to pass all this stuff in. We're giving it the model. We're giving it the tools that it has access to, and we're giving it the messages that we've already given it. So that'll allow it to, see everything it already has in its context from previous tool calls whenever it calls the LLM. What's wrong with this? I'm just going to ignore that error for now. I think it's fine, but if it's not, we will deal with that. So this is something that I think is really weird about these SDKs, is that the way to get the message that you get back is by getting the 0th response from the choices element of the response. I don't know why it's not just like more like here's the response. Because all of the examples tend to get the 0th element from choices, so I don't really know why choices is a response. I guess if you're having the model give you back multiple responses and you want to pick between them, I'm not totally sure, but generally speaking, you're just going to hit the 0th element of choices, and that's what we're going to do here. So this is just going to call the LLM and put the result of the LLM on our messages. Now we want to build the ability for the LLM to call tools. So the way that this is going to work is this tool response is going to be the LLM's response to us telling us to call the tool. So what we're going to do is we're just first going to log that out. So we're going to say, calling tool response dot name, dot function dot name. And they will also give us the arguments of tool response dot function dot arguments. These are going to be coming back from the LLM. So these are things that we can access via the LLM's response. Right, so the LLM is going to respond in a way that gives us access, like gives us an object that has these elements. Okay, so we don't have logging set up. That's fine. We can just jump to the top, import, what am I doing? Import logging. And then we can just say log equals logging.get logger name and logging.basic-config level info. Maybe we do that first. Okay. We're going to log out that we're going to do this. So now what we're going to do is we're going to go into our tool mapping and we're going to get by name the tool that was given to us. So we're going to have to call out this tool mapping is essentially a dictionary that looks like this. So sum tool, and then that'll point at a sum tool that is an actual function. So this is just a quick example, but something like this, right? If this were your tool, you would have a dictionary that looks like this, where the name of that tool points at that function. That is what allows us to take the response from the AI, where they tell us the tool they want to call, and actually map that over to the function that we want to call. So this is going to be in self. And so what we're going to do with that is we're going to call that function with the arguments from the tool. And we're going to get those arguments by loading them from the model's response in the first place. So we need to come back up to the top, import JSON. So now we're going to be loading up those function arguments. And we're going to be calling this tool with those arguments. Okay, so now we have the result of the tool call. We need to put that into our messages. So we're going to say self.messages.append. We're going to throw in a message with the role of tool. And these have this ID that comes from the model. I'm not totally familiar with what that is doing. I believe it's just really for like tracking. But we're going to put that in the message as well. And the tool result. Okay. So now we are getting the name and the arguments of the tool from the LLM's response, which is going to be this function is going to be called whenever the LLM requests a tool call. We're going to get the arguments out of that function. We're going to map over to the actual function using our mapping that will look something like this, which we'll build in a minute. And then we're going to call that with the arguments the LLM asked for. Then we're going to just put that into the LLM's context as a message. Super simple. And that's all we're doing here. And then we're going to return the tool result. Actually, we don't even need to return the tool result. We're not doing anything with the tool result. We're just going to return. Okay. This is the meat and potatoes of what an agent is. This is the agent loop. An AI agent is, at its core, a while loop that continually asks the AI for responses, but those responses are not responses to the user. Those responses are a series of these tool calls. So all it is in a loop, we're saying, hey, AI, you have access to all these tools, and this is the ultimate question that you're trying to answer. And the AI will decide how many times it calls tools up to that limit that we gave it earlier. And every time it calls tool, it will get that content from the tool call added onto its own context so that it can continue to try to answer the question. And at some point, the model will determine that it has enough context to answer your question. That's all an agent is. So let's build that loop. We're going to start at iteration 0, and then we're going to say, while we are less than our maximum number of iterations, increment, obviously, we just call the LLM, get a response. If that contains a tool call, which we can find out by going into the LLM's response, and we can see, did you have any tool calls? And if so, we can say, okay, so now instead of responding to the user, let's call that tool, get that answer, and keep running the loop. So for however many tools it calls, sorry, for tool response, responses, self.call tool response. So right here, we're just taking the response that the agent gave us, where the AI, the LLM, asked us to call a tool. We're recognizing that, and we're jumping up into this call tool function that we saw a minute ago. And that tool response that comes from the AI is what's going to give us access to the function name, the function arguments via the OpenAI SDK, and then we're able to map that over to our own function that we're going to call. If there are no tool responses, we're going to break out of our loop because we're done. The AI is going to call tools in a loop, and then once it has enough context, it's going to give us an answer that doesn't include a tool response. That answer with no tool response is our final answer. So we're going to give that out to the user, and that's why we're going to break out of this loop here. And then when we're done with this, we're going to return the last message, if I can learn how to type. The last message is content. And that is what's going to go back out to the user as the final answer. So this should be, if I can figure out what it doesn't like about this. Okay, I think that's just the LSP being a little bit confused, which is fine. Max iterations is that, but I think this is the LSP just getting a little confused. So we'll move on, and if we run into an error with this, then obviously we'll address it then. So we've built the agent now. The agent exists. Oops. And that is the core of the agent loop. So now we're going to build the tool side of things, because we need to build the side of things that actually enables the agent to have access to these tools. So we're going to build something that's very reminiscent of an MCP style tool decorator, but it's going to be kind of ad hoc in ourselves. So a quick aside on what a decorator is. A decorator in Python is just a function that takes another function. And this is a perfect example of what a decorator really is, right? So it simply takes in that function and then returns that function. So here we can see we define the decorator. When it takes in a function, it defines a new function that is what it's going to return back. But if you'll notice, that new function does something, then it calls the original function, then it does something else. And that is what ultimately is going to happen. So when you apply this decorator like this on top of a function like this, what's going to happen is when you run this function, you're going to get this, then you're going to get the function to run, and then you're going to get this. That is what you're going to get back out as the ultimate function when you run the decorated function. What that allows us to do is populate our tool understanding, our tool mapping and our tool schemas automatically just by writing functions. So this is a little bit long and complicated. It's really not that complicated. It's just there's a few specific things that need to get dealt with in here, right? So essentially what this is doing is it's taking in any function that we want to expose as a tool to the agent and parsing the input arguments and the doc string into a compatible LLM useful string that it can use to understand how to call our function. And so you can see that this decorator, it actually does this all automatically when the function is defined. So the final function that we return from the decorator is just the function. So when you call this function, you don't get, and nothing else happens. All that happens is the function runs. But when you define this function, because we put this decorator on top, all of this stuff gets to happen that helps define to the LLM how to use our tool without us having to do it as a developer. So let's jump and let's build this. So the first thing we're going to do is build a really simple tool, because I think it's easier to understand what you're doing when you have the tool in place to work with and to look at. So we're going to build that really simple sum numbers tool, just like I had kind of just shown. So it's going to take a list of integers, and it is going to return an integer as well. And it is going to return some numbers. But we're going to give it this doc string that's going to help it understand. So we're going to say sum n numbers and return the result. And then we're going to tell it list of numbers to sum. What that represents. So here we're giving it a doc string. This doc string includes a description. It includes the parameter. And so the AI agent will know how to call this. And based on the description, it knows what it's doing. Based on the name, it knows what it's doing. So this will allow the LLM to call it. So let's build the tool decorator, because what we're going to do is we're going to do this. We're going to put this above each of our tools, and that is going to allow the tool to be called and understood by the agent. So let's define that decorator. It's not a good typing day for me. All right. So first things first, we're going to get the doc string. If it has one. And that parse is going to come from the docstring parser that you saw us import earlier. So this is Python package that will give us better ability to parse docstrings and get useful information out of them, which is really helpful for like this kind of thing. It's a lot easier than trying to parse the docstring yourself. So that's going to give us the docstring with as an object. Okay. This is a inspect is a default Python thing that will look into the function signature and tell you what is coming out of the function signature itself, including like type hints and stuff. So So basically right here, I'm saying, you know, if the number of parameters that we're getting out of the docstring does not match the number of parameters that we're getting out of this inspecting the function signature, then we're going to go ahead and throw an error, because that should match. It's obviously not required to match for it to be valid Python code, but I'm saying it's required to match for it to be a valid tool definition so that we can, you know, get everything we need out of it. So this is a very rudimentary implementation of converting Python types to JSON types. Again, this is really just for demonstration, but this is an example of, when we parse these doc strings, the AI is going to need JSON valid types in order to, call things correctly and do its stuff. So we're going to need to convert the Python types that we have into JSON types for the AI to understand our tool calls. And that's just what this is. So we're just supporting really simple data types. We're supporting lists, tuples, which are both just iterables, which are both essentially arrays, and then integers and strings. So super, super simple. But this will get us that. What is it explaining about? Oh, it's just unused. Okay. So that will get us that mapping. And this is where we're going to build up our schema, so to speak, for what the AI will see when we give it access to this tool. So here I'm saying if there's no default for the parameter, then it's required. So for example, if I did this, then this parameter would no longer be required because the AI could call this function without passing anything and it could get an answer because I have this default argument. So I'm saying essentially there's no default here, and if you have a default, or if you don't have a default, then it's required, it's required to be added by the AI as a direct argument pass. Otherwise, the AI can call it however it wants, with no arguments or with arguments. Oh, that's why it's complaining. So now we're gonna get the, okay, you go through annotation, name, and we're gonna default to just the name. This needs to be a get. So essentially what we're doing here is we're saying, if the type of the parameter is in this list, then map it over. So if it's a stir, map that over to string. If it's not in there, just use the name of whatever it is. And we're not going to write any functions that aren't in this list, but this is just a little bit of a safer thing than just direct accessing something that might not be in the dictionary. And then we're going to say that if it doesn't have anything, so if it's empty, then we're just going to set it to a string, right? Because if it's not any of these, then we're just going to say that it's a string because that's something that's valid and easy, and you can put it in anything. You can put any data in a string for the most part. So we're essentially just going to fall back to a string. So essentially here, what we're writing is making sure that the names match. It's just more of a sanity check. So we're making sure that this matches this here. And if it doesn't, then we're going to throw an error. And that's basically just to make sure that the types align between, types and parameters and everything align between the argument list and the doc string. Because, you can write whatever you want, right? So there's nothing enforcing that this matches up with this doc string. So we're kind of doing that manually in here. So we're just going to say type hints do not align with doc string. And then we can even give it so that it's a little more. So we'll say specifically this name from the type hint does not match this name from the doc string. Whoops. Yeah, this is going to be that. Okay. Cool. Next, we're going to just define the parameters for our tool call. So now that we've gone through a lot of this sanity checking, we can actually, define what these are going to look like. So we can say type is going to be this type that we came up with here. So this JSON compatible type, and then the description is going to be the description from the doc string. So this right here is going to be pulling this description. So that is how we're able to give the AI a bit more context on what tools it's actually going to be calling and how it needs to call them. So that we're not just saying like, hey, give me numbers. And then it has to guess, do you want a list of numbers? Do you want a string of numbers? What format do those want to be in? We can just give it a description here. That'll help it get there. And now we're going to deal with lists and tuples, because lists and tuples can have subtypes. So like you see this here, like this is a list, but it is a list of ints. When we move that into JavaScript, we need to be able to parse that, a list of ints, a list of strings, a list of sticks, whatever needs to just be an array. So that's what we're doing here. So what we're saying is we're going to get origin on the parameter. And get origin is actually something from typing, the typing library in Python that gets the sort of origin type. So it's doing that where it's, get origin on the type of list int will give you list. So that's what we're doing here. We're trying to see, is this a list or a tuple? If it is, make sure there's only one argument there. We don't want to handle at this point, at this juncture, we don't want to handle something like this. Or even like that. So we're just going to say if that is more than one, we're just going to throw an error. And otherwise, we're going to set this up. So we're essentially adding the items, adding the items in here for if this is a array type, then we need to tell it what type those items need to be. And that's what we're building up here. We're building up this, this dict that'll look like this. And we're inserting that here, but we only want to insert that if the input is a list. If the input is not a list or a tuple, or some other sort of iterable like that we can map to a JSON array, then we're not going to add that into the function parameters. So now that we've built up all the parameters for the function call, so this is what we've been building up here, is how to deal with all the parameters. Now we're going to deal with the actual function itself. So we're going to get the description from the docstring. So short description is this, and then if you give it like, you know, let's say sums numbers in this specific way that gives a more specific result or whatever, you know, this would be your long description and this would be your short description. So I'm just getting whichever one we have, the most verbose version that we have available. And then we're going to build up this tool schema. And this is where this is going to come together, and hopefully this will make sense. So this is what we're going to send into the AI. So we're going to tell it, hey, this tool is a function. This function consists of these things. So it is called the name of the function, the description, the description is that tool desk that we just built. And then the parameters we say we want to get an object. We want that object to have these properties. So remember, these function params are what we've built up here. This func params is all the information about the particular parameters that get sent into this function. We're telling it which parameters are required. Remember, that was what we did when we looked for default arguments. So if it didn't have a default argument, it was required. And this is what gets sent into the AI. This is our tool schema. It consists of telling it, hey, this is a function. Here's the function's name. Here's what the function does. And here's how you call it. Pretty simple. Now, last but not least, we do the interesting part. And this is where this is allowed to automatically happen as we go through this. So we can add, sorry, not append to a mapping. We want to add the name of the function. And then we want to assign that to the function. So we're going to come up to the very top of our file now, and we're going to define our tool schemas and our tool mappings. Okay, so there is our tool mapping and our tool schema. And then we're going to come down here and populate those. So that list that we defined at the top is going to be available to anything in this file, notably the agent, but we're going to add to it as we define functions via this decorator. So all this logic happens when this function is defined. It adds the name of the tool as well as the actual function. Like, it adds the mapping to call the function that we're going to use that we saw in call tool. You know, that's the mapping we use here to actually call the function. And then it's going to also put in this AI friendly schema into the tool schema. Cool. Last thing we need to do to finish up this function, this decorator, is return out the original function. So we need to define our wrapper, which takes in our args and our quargs. And we just return our function with those things. And then we return wrapper. So now whenever you call this tool, all that's going to happen is the tool is going to get called. But whenever you define a function and give it this kind of syntax, you can simply define the arguments in here and the description here, and then you give it this tool, and it will automatically be populated in and automatically be included in the agent, because we're going to make this one final change to where when the agent is initialized, it pulls in this tool mapping and these tool schemas. So now when we get down here and we initialize this agent, it's going to automatically pull in the tool mapping and the tool schemas from all the tools that we've defined in this function or in this file as functions. Okay. The last thing we're going to do is give it that one last tool. So we're going to give it that tool to search the Gutenberg library, which is that open source repository of books that we looked at earlier. So we're going to do it the same way we do here. So we're going to say, okay, I want to make a tool, and I want that tool to search Gutenberg books. And I want that tool to take in search terms, and I want those search terms, I want those search terms to be a list of strings and now we're going to tell the AI what this tool does. So this tool search for books in the Project Gutenberg library based on the input keyword. Okay, and I'm pretty sure this is supposed to be capital. Okay, so now we've told it what it does. Now, similar to our previous tool, we tell it what those parameters actually need to look like. So we say search terms. This is a list of strings, and I messed this up here, actually. This goes here, part of the like Sphinx stock string style definition. So it's going to be a list of strings, and this is going to be a list of keywords to search for books by. I'm going to copy the URL here. So the URL is that. We're going to say our search terms are just a space separated list of our search terms. And then we're going to call this. So we're going to say requests.get URL params equals, and then we're going to give it our search terms. This has nothing to do with AI. This is just the Gutenberg API, how you hit that. Okay. What is it complaining about here? I think it's a little confused. So let's go ahead and import requests. Oh, and then this be our search terms. Okay. And now I'm going to copy this. This is directly from the Open Router example. So I'm just going to copy. We're essentially just going to iterate through that response and kind of simplify it. So we're going to pull it out into an ID, a title, authors, and we're going to spit that back out. Okay. And now we're done. This is the agent. This is the whole thing. So let's go run it. Okay, I went to run it and I realized there was a small bug, which I'm sure there are maybe others, as is usual with first time writing through code, but I also realized that we forgot to build the rest of the agent calling here, actually calling the agent. So what we're gonna do is it's just a really simple, we're gonna say response equals agent.run loop. So we're gonna run that loop, and then we're going to print out the response prettily, and we're also gonna keep track of tool calls. So I'm just going to go through and count up. So message for message in messages if message dot roll. I guess I should roll equals tool. In agent.message. And then let's also, actually, I'm going to keep that as a print because of the JSON. And then let's print tool calls. Tool calls. I really need to figure out why NeoVim keeps messing up my indentation while I'm writing code. Very annoying. But that's fine. It's probably because there's no except here, and it's upset about that. And then we're gonna also print. Oh, okay. Yeah, well, let's just change this to a log. It's fine. Okay. So this is now it. Let's go try to run it now. Okay, let's go through the diagnostics first real quick and see what's wrong. Oh, okay, this is probably because of that. That's because we didn't return the response from the LLM. We have to do that. And last but not least, okay, I think this is the problem that we are currently left with, is that that was not correctly passed. One other thing we do need to make sure to do is come over here and cast this tool result to a string. Working through a few bugs here, but so it goes. And there you have it. You have a complete agent in, what is this? 190 lines of code with access to 2 tools and the ability to write new tools in a very simple, just functional format where you can just write a function and have it call it tools. So let's try to have it search for some books for us. What are some good fantasy books? You can see it's doing our tool call against the Gutenberg's book API. This will take a minute to come back and fully give us our answer. And there we go. So the Gutenberg API is taking a little while right now to give back responses. So this is actually interesting. It called the search tool twice, but as you can see, it says the search isn't returning results. And I can actually verify that. I'm trying to go in my browser here to the gutendex.com, which is the library, and it appears to be down right now. So this is the agent handling that. It tried to hit the API, didn't get a good answer, tried again, didn't get a good answer, and then gave you some sort of other response. So it looks like the Gutenberg repository is back online. Let's try this again. I'm also going to tell it to only use a few keywords though, because I think it was using too many keywords, which was hurting its search. And there we go. Now we get a nice answer from the LLM telling us here's some good books that it found, Huckleberry Finn, a bunch of other ones. just wanted to show that it was really the repository being down and not the agent not working. Also, before we wrap up, I just wanted to add that I don't necessarily recommend that you build production agents like this. If you're going to build something more on a bigger scale or more for a production use case, you might want to use something like MCP and build MCP tools and build it as an MCP server that you can expose to a lot of MCP compatible clients or something of that nature. But I just wanted to demonstrate the fundamentals of what's going on here so that you can extrapolate that and understand when you're using other libraries or higher level functionality or more complex functionality. And so this is an agent. So the gist is going to be down in the description below. I hope you enjoyed following along. I hope you learned something. If you want to grab the code, feel free to use it for whatever you want. It is I don't think it has a license attached to it, but I will say it is the do whatever the heck you want, and I'm not responsible for anything license. And have a wonderful day.